All right, let's look at two very important special right triangles. So the first one is going to be a right triangle, so it's got a 90-degree angle with a 45-degree angle. Okay, so if this angle is 45 degrees, what's the measure of this angle? Well, remember that the sum of the angles of a triangle have to add up to 180. So if that's 90, these two have to add up to 90. So if this is 45, this also has to be 45 degrees. Okay, then recall from geometry that if you have a triangle with these two angles the same, then we know that this side and this side are the same length. This side is the hypotenuse. Let's call it H. Let's call this side X. So if this side has length X, so will this one. All right, what famous theorem relates the three sides of a right triangle? Well, that's the Pythagorean theorem, which in this case will say that x squared plus x squared equals h squared. Okay. X squared plus x squared is 2x squared. All right, let's solve this for x. Okay, so I'm going to divide both sides by 2. And I'll take the square root of both sides. So I get x equals plus or minus, but since we're talking about the lengths of the sides of a triangle, we'll only use the positive value. So the square root of h squared over 2. All right, so I can take the square root of the top and the square root of the bottom. So this will be the square root of h squared over the square root of 2. The square root of h squared would just be h. I'll get h over the square root of 2. I want to make this look a little better, so I'm going to rationalize the denominator. So remember, to rationalize the denominator, I'm just going to multiply by the square root of 2 over the square root of 2. So this is just 1. I'm not changing this value at all. I'm just multiplying by 1. Anything divided by itself is 1. All right, but what this does then is causes me to have a rational number on the bottom. Square root of 2 times the square root of 2 would just be 2. And here I would get square root of 2 times h. All right, so what this says is that if I have a 45, 45, 90 triangle, then this length, the length of the leg, is equal to the square root of 2 over 2 times the hypotenuse. Okay, so that's a very important fact. If you have a 45, 45, 90 triangle, the leg is equal to the square root of 2 over 2 times the hypotenuse. All right, so now let's suppose that we have an equilateral triangle. So all three sides are the same. So this side is equal to this side is equal to this side. If you have an equilateral triangle where all three sides are the same, then that tells you that all three angles are the same. So this would be 60 degrees, this would be 60 degrees, and this side would be 60 degrees. They all add up to 180. And here's the trick now. I'm going to split this triangle right down the middle. Okay, so I'm going to cut it right down through here. Okay, so if I cut this down the middle, you can remember from geometry, or it's fairly intuitive, that this will be a right angle. Okay, so this comes in perpendicularly. And you have two exact copies of this triangle. Right. Remember that all three sides are the same. So let's say that this is side, well, let's see, what do we want to call it? Let's call it H. And I'm calling it H because notice that this side is the hypotenuse of the triangle on the right. So if this whole side is H, how long is this side? Now this side would also be H. h. How long is this side? Well, it would be h, all the way across. All right, but now let's just focus on this triangle on the right triangle. So I'm going to redraw it over here. Okay, so this is just a copy of the triangle on the right here. So what's this angle? Well, it's 60 degrees. What's this angle? Well, this was 60, the whole thing. We split it in half, so now this is 30 degrees. Okay, so our second special right triangle is a 90, 60, 30 triangle. All right, how long is this side? Well, we called it h, and it's the hypotenuse. Okay, how long is this side? Well, the entire side was h, so if I have half of it, this would be h over 2. All right, let's call this side x. All right, so in terms of h, this side is h over 2, so we know it. But what about this side? We want to write this side in terms of h, or in terms of the hypotenuse. So let's do that. What famous theorem relates to three sides of a right triangle? That would be the Pythagorean theorem, which in this case says that x squared plus h over 2 squared equals h squared. All right, let's simplify. X squared plus, if I square h over 2, I'll get h squared over 4 equals h squared. And I want to solve this for x, so I need to subtract h squared over 4. So x squared equals, well, if I've got 1h squared and I subtract 1/4 of an h squared, I'll have 3/4 of an h squared. Get a common denominator, this would be 4h squared over 4 minus 1h squared over 4, leave me with 3h squared over 4. All right, take the square root of both sides. I'll get plus or minus the square root of this, but we really are only concerned with the positive answer, so square root of 3h squared over 4. All right. I can take the square root of the top and the square root of the bottom. If I do the square root of the top, I'll be left with the square root of 3. And then the square root of h squared is just h over square root of 4 is 2. All right. So very importantly, if you have a 30, 60, 90 degree triangle, in terms of the hypotenuse, the side opposite of the 30 degree angle is the hypotenuse divided by 2. The side opposite of the 60 degree angle is the square root of 3 over 2 times h. Okay, so let me say that again. So 30, 60, 90 degree triangle, the side opposite of the 30 degree angle is half the hypotenuse. The side opposite the 60 degree angle is the square root of 3 over 2 times the hypotenuse.